Hi, my name is Kachur and I'm working as a performance engineer in Volt. So today I'm going to talk about debugging performance issues with JDK flight recorder and try to show what you can do with that and why it's really great tool. So when I started as a performance engineer, I was desperately trying to search like uh, some some presentation about how to use Profiler, what you can do with the information that it provides. And so, well, this is my attempt on such a talk. Initially, I was going to motivate like using profiling by putting this into a context of CPU development, into a Moore's law that, despite the transistor count, is still growing linearly. We are already facing a ceiling on single thread performance, on a frequency, and typical power density is still like hitting the ceiling with 100 watts. And despite the number of logical cores is still growing due to Amdahl's law and contentions, it's really hard to expect like really great performance boosts or like as they were 20, 30 years ago. So much bigger issue, at least for startups, is downtimes. So for example, APM can provide only limited set of data like latency and drop requests per second. Uh, and it's really hard to actually pinpoint the problem and find the root cause of it. But with right tooling, it's possible to do and it's quite easy to do. So for example, during this performance issue that almost ended up with a downtime, CPU cores utilization and memory allocation was really growing rapidly and pretty huge, as you can see, allocating around 2 gigabytes per second. And it appeared that it was like the reason was the garbage collector and initially we ended up fixing this. According to JRebel's questionnaire and report, the most common performance issues that developers facing is long application response time, high CPU usage, memory leaks, too many open connections, and other I/O related problems. So actually using Profiler can help you with almost everything included in this list, and profilers really can help. Of course, they can also help with performance optimizations. For example, excessive allocations can ruin performance like for single endpoint or for whole service. And with proper tools, these such kind of issues can be easily tracked and fixed. For example, during like preparation for this presentation, I took the T-Store application, which is specs benchmark for microservices, and it appears that fixing really small performance issue related to allocations can increase the throughput like to 20 to 30% and decrease latency by like 10% or something like that. So what kind of tools do we have for like to track such problems? According to another report by JRebel Labs, we have Visual VM, gprofiler, Java Mission Control, which is a front end for GFR, and YourKit. Well, those are basically were dominating on the market like 5 years ago. So is it too old? Well, kinda yes, it's too old. 5 years ago in IT is pretty long time, and today we have much better tools to choose from, and they are better than 5 years ago. Like much better. For example, set point bias problem in all Java profilers could be considered as a solved problem as for now. Initially formulated 10 years ago by Jeremy Manson, it's a software engineer from Google, and further developed by Nitsan Walkart and Andrei Pangin, who created Async profiler at the end. So things changed drastically, and nowadays production profiler no longer a privilege of Google or Facebook and even Amazon, like providing solutions like Code Guru profiler. I was keen about production profiling for a long time, and glad that finally industry is ready for it. Initially, I've started with Async profiler, but despite it's great, it's a bit problematic to deploy it on production because of like internal structure and tightly coupling with operating system. Then when AWS Code Guru was announced, I was really excited about that, but it's lacking on features and sampling rate of 1 per second. It's ruined it for us. So since like it's really hard to execute spike analysis with it, and well, it's hard coded, so no way to change it. So after upgrading to Java 11, we came to using GFR, and it's been really great. So according to Alexei Shipilov's curve of performance, while your performance issues placed in this green zone, which is issues caused by a lack of attention to them. It really doesn't matter which profiler you will be using, so pick like any from this list, it will help you a lot. But why GFR at the end? Well, what actually GFR is? And GFR is not actually a profiler. It's an event recorder built into Java Virtual Machine, and well, it is actually a part of virtual machine, which was designed to minimize observer effect and have low overhead. And well, it actually has low overhead. So pros that coming from it is that no need to install at all, like anything, it's already built in. And starting from Java JDK 11, it's already there, but even if you are using JDK 8, it's there. It was backported in version 262 like a year ago or so, so it's very easy to run. It have small overhead, and to execute it you can use like JVM arguments, a command line interface like GCMD, and GMX interface, or even API, like create your own runner or library. As for cons, well, the only thing is like no proper operating system integration, so well, no cache misses, no page faults, no branch mispredictions, unfortunately. But yeah, despite it's not a silver bullet, it really looks like one. Since I've started with memory allocation problem, let's discuss it in depth and start with memory. Problems like excessive memory allocations caused by immutable or recursive data structures, or creating large objects that doesn't fill into TLAB, causing extra synchronization overhead. So these kind of problems could be easily solved with memory allocation view, not to mention problems caused by out of memory killer or memory leaks. All of those could be tracked with GFR. Unfortunately, no page faults, but yeah, that's price to pay. So for those who are not familiar with flame graphs, I can recommend like talks by Brendan Gregg. He's popularizer of profiling and flame graphs. So basically, like in a nutshell, what flame graph is, it shows the number of stack samples that been recorded during profiling session. So here we can see that huge amount of memory allocation caused by hash map resizing, and color is something related to GSP tag F format number, which leads to more pressure on GC. So GC, automatic memory management, made us think that new allocations are free, since we no longer need to allocate memory nor free it. But unfortunately, it's not that simple. It's not free. So it causes CPU load, tail latency, and low GC cycles. That's the price to pay for such a convenience. In the end, it's always memory versus CPU trade-off, and GC is like directly in between of them. So what we can track is longest pause caused by like some particular GC stage, or graph visualization of cycles, and of course like histogram of pauses. I'm really excited about ZGC and Shenandoah, and they will improve our lives a lot by like increasing throughput, reducing pause time, but allocations and CPU utilizations is still problems that we should keep track on. Yeah, and now we are coming into CPU. Well, obviously the reason for about CPU, because like it's present in any profiler that is available for Java. But one thing to keep in mind is stack depth. So what the stack depth is. While profiling, you're collecting stack traces, posing GVM, and like each pose producing a stack trace, like in exceptions, for example, and you're JFR just collecting them and storing. So the size of this stack trace by default is 64 stack frames. So if you are dealing with Scala, for example, it's definitely not enough and should be increased. So what we can see on this graph? Well, it's our friend from memory allocation slide, F format, number, GSP tag. So same problem could be seen on many levels and CPU and memory, and this is like what actually causing GC pauses. So it was like caused by really old code, at least 5 years old, unnecessarily creating quite big localization object, and fix took like 5 to 10 lines of code. So this is what exactly green optimization zone is, and that's how it can be improved. As you can see, such issues are pretty easy to trace and eventually fix. But what if you are working with some async frameworks like Vertex or something similar, so that your asynchronous execution is not part of an initial thread? Well, in this case, GFR can provide some thread-related information. How it works? Well, it actually align every collected stack trace to thread in which it was initially created, and by this you are just pinning all of those like async traces without the parent to the actual thread that's been executed. So it is a very useful thing, because we are like dealing with a lot of asynchronous stuff, and sometimes it's really hard to track. So on this slide, for example, we are seeing Tomcat threads, and if you're interested into like Tomcat performance, I can recommend you talk by Brendan Gregg, who compared Tomcat versus NetTeam in Netflix probably 3 or 4 years ago, something like that. So another thing that GFR can help you to track is thread leaks. Recently, a friend of mine mentioned that in the chat there was a thread leak discussion, and someone recommended old good way of dealing with it is just making a thread dump and heap dump and comparing them and checking the diff. But it's like it's really troublesome to do that. Much easier way is just to execute GFR profile, to collect GFR profile and open it in Java Mission Control, for example. And well, that's actually what's going on here. We've experienced some annoying thread leak problem when on every run of our service in several hours, thread count stabilized around at 4.5k threads, and we couldn't find the cause of it like for half of a year or something, no matter what we've tried, because like everything was asynchronous, as you can see, Amazon SNS Async client, and the thread name uh, actually doesn't tell you anything. It's just pool, number, and whatever. So when you're making a thread dump, it's just like sleeping or running and no stack traces there. So it was really annoying problem to track, but with GFR it took like, I don't know, an hour or so, maybe even less. So it's really a powerful tool to track such kind of issues. And of course, like there is Visual VM inspired view. So if you are used to such kind of representation, so here it is. Kind of opposite to tracing async executions, it's logs, and there are like a lot of problems with logs, such as like log contentions, race conditions, and even dead logs are usually pretty hard to track down and solve. So when a thread holding a common log, for example, it can prevent other threads from execution, and such behavior on APM side may be shown as a service performance degradation without any extra resource usage. And in big projects without proper tooling, it could take huge amount of time to find the root cause of such problems. And here comes this really nice log tracing feature. And as you can see here, most logs are coming from network layer actually trying to acquire a connection or release it. So yeah, now that network layer brings us to actual I/O and what GFR can show you related to well, to I/O. Microservice architecture can make it really hard to track all types of connections that service is using. That's why observability is so important nowadays in understanding how systems behave. But how to understand what happens within the connection, like inside the pod or inside the service? Well, this view can help with tracing such kind of issues. For example, slow third-party service response time, or method that suffers from network timeouts, or like all kind of different stuff. So that's more or less what I've decided to put in a general part of like what GFR/GM Java Mission Control can provide you with. And here are a couple of issues that have been solved with GFR in Vault and all saved a lot of time to our users. So one of the first things that GFR helped to track is problem with play.json. Play.json is using recursive JSON serializer, and well, it's not so good design as you might see. Since it represents every JSON document as a set of immutable fields, it allocates huge amount of objects and consumes a lot of space in heap and stack, and switching to more resource efficient serializer like JSONeater improved things quite noticeably, as you can see, like improving latency by like 2 times or something like that. Another interesting thing is well, what may be perceived as a memory leak, in fact, is not, is thread leak. And it was caused by Kafka producer, and it was really easy to overlook. For example, if you are using only APM without like digging further in what happens inside your application. So yeah, that's really nice tool to use. There are lots of such performance issues that GFR helped to track, and those two was just a small fracture of them. So initially I've used GFR setup with JMX interface and files produced on pods, but when Marcus Hirt left Oracle to Datadog and Datadog announced production profiler, we've decided to use this profiler since it's just a wrapper around GFR, and it integrates really nicely with their APM. Well, that's how it looks. And besides adoption in Datadog, GFR is gaining really a lot of attention from other companies. Of course, there is GDK mission control, which is a front end for GFR, and helps analyze profiles, as I've already mentioned. So also it's adopted by New Relic, by Red Hat with their container GFR project, which is cloud native open source solution for GFR setup similar to Datadog. Also it's integrated into Visual VM. There is integration with GMH, which is benchmarking harness for Java, and with time it's evolving in new features, introducing like event streaming, which should reduce overhead even more. So to pick one thing to take away from this talk is just try it. If you never tried it, please do. It's really easy to use. So it's like, if it's not simple, I don't know what it is. There are two options actually to provide start flight recording parameter on a startup, or even even if your service is already running, you can hook up to it with GCMD to already running instance on production, for example. Or if both of those methods are not so convenient, there is GDK mission control, and you can use graphic user interface for recording. If you will port forward, for example, a GMX port to your local machine, you can execute this even remotely. So as for me, no profiling profiling is a game changer as much as introducing tests into your project or hooking up APM. So despite it's not silver bullet, in many aspects it looks like it. So here is links. A lot of this talk was inspired by these nice guys like Marcus Hurt, Isuru Pereira, Jeremy Manson that I mentioned, Brendan Gregg, of course. I want to thank you for attention, and of course I want to thank those guys like giants on shoulders of which we stand. So Marcus Hurt for GFR and dedicating more than 20 years to this project. Brendan Gregg for flame graphs and popularization of performance engineering. Jeremy Manson, Nathan Walkert, and Andrei Pangin for bringing attention to safe point bias problem and creating Async profiler. So thank you. That's it.
Thank you, Alex. Really cool stories. One thing I know on our side when we think about profiling is that we love to get profiling data from production, but it's an expensive proposition. So I'm wondering, in your work with GFR, do you have some recipe you use?
GFR so far looks pretty great. As for overhead, it's less than 3% of what we've been measured on production. That's a part of the story why I'm advertising it, because this is really great tool, and unfortunately for Python, for example, or for JavaScript, it's much more troublesome to have anything similar. For Python, for example, there is PySpy, but unfortunately not as wide infrastructure there for this profiler. For JavaScript, it's even worse than for Python.
So do I get this right, that you're running on all your services, or you just sample on some of the instances you run profilers to get data of actual production loads?
At this point, we are running it on on our Scala-based services, but on a sampling, sampling several pods, let's say. So on all services, but on several pods, just to
Yeah, exactly. Yeah, we're also looking at something similar. Certain. Okay. Superb.
Well,
thank you so much for your time.